Hi everyone. In this video we are going to discuss about permanent magnet brushless DC motor. Before going to the brushless DC motor, we will discuss about the conventional DC motor. In conventional DC motor we have stator and rotor. Both stator and rotor will have a windings. And stator may have winding or may be a permanent magnet. So stator consists of a field winding and rotor part consists of a stator winding or armature winding. This armature winding is fed through the commutator and brushes. So this commutator and brush is providing a connection to the external circuit. So the major drawback of this conventional DC motor is this commutator and brushes. So this is the commutator arrangement. Now it depends upon the number of parallel path in the rotor winding. There is number of segmented part in the commutator, and this brush is fixed at a particular path, and this commutator is continuously rotating. Um, these brushes are collecting a current from the this segmented commutator. So one segment, when the brush crosses from one segment to another segment, there is a possibility for sparking. So this sparking is causes a most dangerous thing in some hazardous places, environmental places like cotton mill or something like that. Okay, so this is the major drawback of this conventional DC motor. So to overcome this, we are going for a brushless DC motor. So in case of brushless DC motor, we are going to change the winding. That is, the rotor consists of a permanent magnet, that is field winding, and the stator part will have a armature winding. So since the stator part is having a armature winding, we directly fed the supply to the stator armature winding, and rotor consists of a permanent magnet. So there is no requirement for commutator and brushes. Rotor rotates based on the position of the rotor with stator poles. So rotor position are sensed continuously by using some sensors. So current through the each coil is controlled by the external electronic switches, that is power converters. So this is the basics of brushless DC motor. So when you see the advantages and disadvantages of brushless DC motor, the advantages are the reliability and efficiency is increased, and less or no maintenance. You can say zero maintenance because we are removed the commutator and brushes. So the wear and tear is reduced. So the maintenance is reduced. So there is no problem in the commutator circuit. So reliability can be increased, and there is no winding in the rotor circuit. The rotor copper loss is reduced. So the efficiency can improve. Then, since we have removed the commutator and brushes, the length of the machine is reduced. Then this brushless DC motor is a self-starting motor, whereas the conventional DC motor requires some starters. So it does not require any starters. Speed can be controlled by using a external circuit. Motor can be utilized in any hazardous conditions because there is no sparking in this brushless DC motor. Then look into the disadvantages. Uh, there is no field, so we cannot control the magnetic field of the motor, and it requires some additional sensors, rotor position sensors, to exactly sense the rotor position. and it requires a complex converter circuit, driver circuit for operating this motor properly. So these are the disadvantages. And types of brushless DC motors. There are two types of brushless DC motor. One is called inner runner brushless DC. Both are same principle. The only the difference is in this inner runner brushless DC motor, the rotor consists of permanent magnet is placed inside the winding, which is placed in the stator or yoke of the machine. So the rotor is connected to the shaft. So rotor continuously rotate and stator is permanently fixed to the body of the machine. So this is called the in-runner brushless DC. And another one is outrunner brushless DC. In this, the outer part is having a permanent magnet and the inner part will have the armature winding. But here the rotating one is outer part. The inner part is going to be stationarily fixed. This outer part will rotate. So these type of machines are called outrunner brushless DC motor or otherwise hub motors. So this is very much used in the electric vehicles. So these are the two types of brushless DC motors. And coming to the working principle, the working principle of this brushless DC motor is same as your brushed DC motor. The only thing is we are replace the field winding with a permanent magnet, and this permanent magnet is fixed in the rotating part, either inner rotating or outer rotating. Wherever we have a rotating part, in that we have a permanent magnet. The other stationary part will have the armature winding. And another difference is internal shaft position feedback. Since this brushless DC motor requires the shaft position feedback, we are going for feedback by using some hall sensor or optical sensors in the stator part. We will fix the sensors in the stator part. It continuously monitor the rotor position. It gives the feedback to the control circuit, so it will take care of the energization of the particular phase winding and the armature. So the current direction of the stator conductor are controlled by the external electronic switches. This type of thing is called electronic commutation. Whereas in the conventional DC motor, we are having a commutation circuit, that is commutator and brush circuit arrangement. So this will help the this will take care of the commutation. But here that type of commutation is called mechanical commutation. Here we are using a electronic commutation. That is, we are not having an exact commutator there. Instead of that, we have a additional external electronic circuit, or it is called power converters. These converters are taking care of this commutation. So this is called electronic commutation. So when you see the force produced by this motor, the force produced by is proportional to the, or it depends upon the current through the conductor and length of the conductor and magnetic field produced by the field winding. That is, here it is a permanent magnet. So here the magnetic field is fixed. We cannot change it because it is a permanent magnet. So we cannot control the field. So the field is fixed one. The only thing is we can control the current. When we control the current, the force will be produced. Then torque of the motor T equal to IBA sin theta. I is the again current through the conductor. B is the magnetic field which is fixed, and A is the area of the winding. That is A equal to L into W. L is the length of the winding. W is the width of the winding, and theta is the interaction angle between the stator and rotor. So here also we can control the current alone. So based on this, the torque will be produced in the BLDC motor. When you look into the applications, it is very since the motor is very compact one and it is having less weight, so it is very much used in the aerospace and aeroplanes. And the second one is automobile industry. As I already told you, it is very much used in the electric vehicle in recent days. And then consumer electronics like washing machine and other consumer electronics, we are using the BLDC motor. Factory automation equipment. In factory automation equipment, it is used as a activators. For example, door opening system or whatever it may be. So it is very much used in the factory automation system. And industrial machinery. I already discussed many of the hazardous situation. We cannot use a conventional machines because it may produce a spark, so it will damage the entire infrastructure. So to avoid this, we can go for a brushless DC wherever the environment is very hazardous one. Then instrumentation. Again, it is very accurate, so we can use it in a instrumentation system. Medical electronics is similar to the consumer electronics. And military applications, again, it may be used in a electric vehicle or some other systems. The last one, it is not a simple one, it is very much popular one. It is called the robotic system. In robotic system, the BLDC. Okay, thank you.